Hello and welcome to the session. In this session, we are going to discuss the following question, and the question says that find the directional derivative of f of xy equal to x square plus 3y square at p in direction of q, where p is at 1, 1 and q is at 4, 5. If suppose z is equal to f of xy, where partial derivatives of the function exist, then gradient of f is denoted by del f or del f of xy and is found using the formula del f is equal to, or gradient of f is equal to del f by del x I cap plus del f by del y j cap, and directional derivative for function z is equal to f of xy, where f is a differentiable function in direction of unit vector u, is given by d sub u of f of xy is equal to the dot product of gradient of f of xy and unit vector u. We have f of xy is equal to x square plus 3y square, and we have to find its directional derivative at the point P in the direction of q, where p is at 1, 1 and q is at 4, 5. Since partial derivatives of f are continuous and f is a differentiable function, so we will use gradient of f to find its directional derivative. So here the directional vector will be vector pq. Now we know if p is at x1, y1 and q is at x2, y2, then the vector pq will be equal to x2 minus x1 I cap plus y2 minus y1 j cap. So here vector pq is equal to vector u, which is equal to 4 minus 1 I cap plus 5 minus 1 j cap, which is equal to 3 I cap plus 4 j cap. Now let us check whether this vector is a unit vector or not. Now for this we find norm of u. Now if the vector u is equal to x I cap plus y j cap, then norm of u is equal to under root of x square plus y square. Therefore, here norm of the vector u will be equal to under root of 3 square plus 4 square, which is equal to under root of 9 plus 16, which is equal to under root 25, that is equal to 5. Now, since norm of u is not equal to 1, therefore vector u is not a unit vector. So we will make it a unit vector. So unit vector of u, that is u cap, will be equal to the vector u upon norm of vector u, which is equal to 3 I cap plus 4 j cap upon 5, which is equal to 3 by 5 I cap plus 4 by 5 j cap. Now we find gradient of f of xy. From the key idea, we know that gradient of f is equal to del f by del x I cap plus del f by del y j cap. So we differentiate f partially with respect to x and y. In the formula, we get gradient of f is equal to del by del x of x square plus 3y square I cap plus del by del y of x square plus 3y square j cap, which is equal to 2x I cap plus 6y j cap. As 2x is the partial derivative of x square plus 3y square with respect to x, here we keep y as constant, and 6y is the partial derivative of x square plus 3y square with respect to y. Here we keep x constant. Now we need to find d sub u of f of xy, which is equal to the dot product of gradient of f of xy and the unit vector u. Now we put the above found values in this formula. We get d sub u of f of xy is equal to 2x I cap plus 6y j cap dot 3 by 5 I cap plus 4 by 5 j cap. Now when we evaluate the dot product, we get d sub u of f of xy is equal to 2x into 3 by 5 plus 6y into 4 by 5, which is equal to 6 by 5 x plus 24 by 5 y. Now we have to find the directional derivative at the point P 1, 1. So we will have to put x is equal to 1 and y equal to 1 in directional derivative. We get d sub u of f of xy is equal to 6 by 5 into 1 plus 24 by 5 into 1, which is equal to 30 by 5, which is equal to 6. So this is the required answer. This completes our session. Hope you enjoyed the session.